Hi friends, I'm back with a new video. Micrometer screw gauge. Okay, today we'll talk about micrometer screw gauge, how to take the reading through micrometer screw gauge. Alright, to begin with, this is micrometer screw gauge. Okay, when you talk about the micrometer screw gauge, we have got various parts of the micrometer screw gauge. Okay, to begin with, you can see this U-shaped thing. Okay, this U-shaped thing which you can see is nothing but called as U-frame. This is called as U-frame. Okay, to go with the next part is nothing but here. Can you see this small part which is coming out here? Okay, this is called as stud, or we also call it as anvil. Stud or anvil. Okay, in front of it there is one more part out there. Okay, this part is called as spindle. So U frame, this is called as anvil, and this is called as spindle, right? Okay, now coming to the next part. If you can see this part here, okay, which is extended, suppose I open this and I can see this part here. This part is nothing but called as datum line, or we also call it as main scale line. Okay, so this is main scale or the datum line. Going to the next part is this one. This is called as, this is looks circular shape here. Look at the pointer here. This is circular in shape, and this circular shape which is out there is called as thimble, or we call it as circular scale. So let's have a revision of all these once again. You can see that here the part which is coming out here is called anvil. Okay, this one, and here we have got a spindle. This is U frame which I'm talking about. Then we have a datum line, okay, which is also called main scale, and followed by there is something called as thimble scale or circular scale, and in the end we have got, there is something called as ratchet. This ratchet is nothing but the one which we use to close the micrometer screw gauge. Okay, so once it makes a tick sound, means the micrometer screw gauge is shut or closed. Okay, we're not supposed to go further, right? So once again we'll have a quick revision of this. Okay, so here the first part, this is U-shape frame, this is called as anvil, this is called as spindle, this portion is known as datum line, or we call it as main scale. This circular scale is, either you call it as circular scale or you call it as thimble scale, and the last one is called as ratchet. So when we shut it, when we close it with the help of this only, we close it, and once you get the tick sound we stop it. So this is all about the introduction. One more thing I have to tell you, that on this U shape frame you can see there is something written 0 to 15, means it can give you the maximum 15 millimeter the reading, 0 to 15 millimeter, nothing beyond that. So the maximum reading which you can get here is 15 millimeter. Alright, okay, let's start taking the least count. Okay, before we taking the least count, I just want to show you a few things out here on micrometer screw gauge. Can you see these lines here? Okay, if the moment I have taken thimble backward, you can see there are lines here. Now here, if you look at this, each line, that is 1, 2, 3, 4, and this is a fifth one. There is 5 written over there. Okay, I'll just show you. It's written as 5. Yeah, can you see 5? Yeah, it's written 5. Okay, if I further take you, okay, it's written 10. Next, here it is, this is 5 and this is 10. Now what does it mean? Here each line stand for 1 millimeter. Okay, each line, so there are 5 lines. The fifth line is this one, this is the 10th line. Each line stand for 1 millimeter, means if I want to take out least count of this micrometer screw gauge, I have to keep this in mind, that what is the one division stand for here on the main scale, which is going to be my pitch. So here I write calculate least count, first we need to have a pitch. What is pitch, everybody? Pitch is nothing but the minimum division, okay, the smallest division the main scale has. So you can see here is the pitch is 1 millimeter. Okay, when I showed you that, I told you that here in this micrometer screw gauge here, each division is 1 millimeter. Okay, I made you show that here each division is 1 millimeter, so that's become pitch. So pitch is 1 millimeter here. Now when I go onto the thimble scale, okay, thimble scale is nothing but the circular scale we have. Okay, so you can see that the circular scale we have here is the number of divisions on the circular scale what we have is 100. So here if I show you here, the number of circular scale divisions will be, yeah, so the number of divisions on circular scale here, you can see this is the thimble scale, and on this thimble scale is the number of circular scale division is 100. Okay, so least count is nothing but pitch upon the number of circular scale divisions. So we have got the pitch is nothing but the minimum count on main scale, which is 1, divided by the number of circular scale divisions, which is 100. So if I divide it, you get the answer as 0.01. okay, 0.01 mm, that is millimeter. So your least count is 0.01 millimeter. Okay, this is in millimeter. If I want to convert into centimeter, I can do that. So it's become 0.01 divided by 10, which has become 0.001 centimeter. This is your least count. So whenever you're taking any reading, you're supposed to multiply with this least count. So the least count is of this micrometer which you're going to use here will be 0.01 centimeter or 0.01 millimeter. Okay, so let's have a quick revision again. Okay, I'll tell you how to calculate so you don't forget that. Okay, so how do we do that? How to calculate least count? First we need to find out pitch. What is pitch? Pitch is nothing but the minimum measurement possible on the main scale, that is 1 millimeter, which is there. Okay, second is nothing but we need to find out the number of divisions on circular scale, which is 100. So the least count is nothing but the pitch upon the number of circular scale divisions. So pitch is 1 upon circular scale division is 100, so 1 upon 100, and here the answer is 0.01 mm, that is millimeter, is your least count. If I divide by 10, I get 0.001 centimeter as the least count. Right? Alright, let's start taking the reading, everybody. So reading can be taken in the steps. A few things you need to keep in mind. For example, here is when I'm talking about MSR. MSR stands for main scale reading. Okay, second comes CSR. CSR stands for circular scale reading. And this third one is, that is least count, is LC, that is least count. So in the table we have got certain columns. Look at the serial number, that is the amount of reading which you're taking. Then we have got MSR, which is main scale reading, then CSR, which is circular scale reading, then CSR multiplied with the least count, and then final reading will be the main scale reading and this C1, that is circular scale reading, into least count. This will give the final reading. Alright, so let's begin here. Alright, I have a rod attached to this micrometer screw gauge. Okay, and how to make sure that it's fully tight, just rotate this ratchet and you will find that there is tick sound is there heard. Once you hear the tick sound, then you can actually start taking the readings. Right, so let's take the reading. How to take the reading here is, you have to look at the main scale now. Okay, so when I look at the main scale here, you can have some idea. You can see that, okay, the number of divisions which are there on the main scale here would be, so once you look at the scale here, you will find that the main scale we have got 4 lines on the main scale, that is 1 2 3 4. So there are 4 lines on the, that is the 4th line is just coinciding with the circular scale here. So you will see that the main scale reading would be 4, 1 2 3 4. So that is 4 is the main scale reading. So let's write down this. Main scale reading is 4. So here I've written 4. Okay, now I'm supposed to look into the circular scale reading. So here is, you have to see that which point is coinciding with the datum line. So the datum line which we have, the main scale, there's a line here, right? This line is coinciding with the which number on circular scale, that you're supposed to find out. So let's find out which number is coinciding. So once we see the circular scale reading, we find that the 84th line is coinciding here. It's a little difficult to see because the lines are very small, so it may not be that visible. I tried my level best but I couldn't, but then I can see that it is 84th line of the circular scale is coinciding with the datum line. So I just write here. So in the table now, table we have got circular scale reading, which is coming out to be 84, right? So 84 is multiplied with the least count. Okay, the least count we had just now find out. So like when we had found out what is the least count, do you remember that? Least count was 0.01 millimeter or 0.001 centimeter. So since our readings are in millimeter right now, so we'll be taking so CSR 84 multiplied by least count, and the reading will be 0.84. okay, so 0.84. now you need to add A and C. So let's A and C will be added in the last column. So is 4 and this is 0.84, so it will become 4.84 millimeter. So finally your reading is 4.84 millimeter. So the diameter of this particular rod is 4.84 millimeter. Thank you very much. Yeah, for the better accuracy we can have the second reading coming up. So let's see what is the second reading. So here is, we close it. When we look at this is again 4. So we got main scale reading as 4 again, and we look at the circular scale reading now. Circular scale reading. So our circular scale reading is 80. Our circular scale reading is 85. So let's list it down here as 85. Okay, we'll multiply this 85 by least count, which is 0.01. so here is 0.85. okay, now we need to add 4 plus this, that is because the final reading is A plus C, so it's become 4.85 millimeter. Alright, so I have taken 2 readings. You can take one more reading and then take the average, or you can take these 2 readings and take the average. So I'll take the average of these 2 readings here. So it goes like this. You can add and divide by 2. So it goes, let's have a calculator, 4.84 plus 4.85 divided by 2, and the answer is 4.845. So this mm. So finally this is your the diameter of this particular rod. Thank you very much. Don't forget to subscribe my channel.